Okay, question 1.122 on the board. A disk of mass m slides with the zero initial velocity down an inclined plane set at an angle alpha to the horizontal. Having traversed the distance L along the horizontal plane, the disk stops. Find the work performed by the friction forces over the whole distance, assuming the friction coefficient is K for both inclined and horizontal planes. Okay, let's draw this diagram. So this is an inclined plane. Okay, and the disk, it starts from here. It is let go. So initial velocity is 0. So it would slide down here. So it's not rolling though, it is sliding. Okay. And then once it reaches this horizontal plane, after a while it comes and stops here. Okay. So this distance is given as L. This angle is given as alpha, and the mass of the disk is given as m. Okay, nothing else is given. And oh yeah, so and the coefficient of friction on both these surfaces, this surface and this surface, we can assume it as K. Okay, now the question is worded such a way some students might get confused as to what is happening, but this is what is happening. So but once you have the picture, remainder thing should be pretty simple. Okay, so let's look at that. Now let me mark these points as A, B, and this point is C. Okay, now during the journey AB, if I look at the free body diagram of the mass m, there is mg, there is normal reaction, and there is some friction force which is opposite direction to the relative motion. So let's say that as F. Okay, or maybe we can write FAB. Okay, there are no other forces. And then during BC, what happens is there is mass mg. There is a different normal force now, let's say n dashed. Okay, normal reaction. And then friction is this side, this is FBC. Okay, now, so this is journey AB and this is for the journey BC. Okay, from here we can write, so this angle is alpha. So from here we can write N is equals to mg cos alpha. So therefore friction force AB is Kn, so it is Kmg cos alpha. Okay. From here we can write N dashed is equal to mg. So friction force BC is Kmg in this case. Okay. Now let's look at work energy theorem. So what does work energy theorem say? So work energy theorem says work done by all forces is equal to the change in kinetic energy. Now we started from point A, the mass was at rest, it was let go and then it started sliding down and it stopped at point C. So the change in kinetic energy in the entire journey from A to C is 0. So we can now break down the work done by all the forces, and we have listed down all the forces right in these two diagrams here. So let's write work done by friction force AB plus work done by normal reaction N plus work done by gravity in the journey AB plus work done by friction force BC, then work done by normal reaction N dashed, and work done by gravity in the journey BC should all be equal to 0. Okay, now there are few obvious things that we can find out. Work done by this normal reaction and N dashed is both 0 because the displacement is perpendicular to the normal reaction. So this term and this term are 0. Okay. Now let's look at the easy ones. Work done by gravity in the journey from A to B. Now we don't know this distance. Let's say this distance is C. Okay. So we can say that work done in this, so along C, the component of gravity is mg sine alpha. So this one becomes mg sine alpha times the displacement C. Okay, so we accounted for this work done. Now the other easy one is this one, work done by gravity in the journey BC. So now gravity is downward, but the displacement is happening in the x direction. So this one is also 0. Okay. So then we have to find out the work done by the friction forces. Okay. So work done by friction force AB is the force AB, so which is K mg cos alpha, right, times the displacement, which is C, and work done by friction force BC. Oh, wait a minute. This has to be minus because the friction force is opposite to the direction of displacement. And work done by friction force BC, again this is minus because the displacement is opposite to the direction of friction force. So K mg L, and this should be equal to 0. So from here I can see the only unknown is C. Now we can actually cancel out mg, mg, mg. Okay. So we are left with, let's take C common from these two. So C common is sine alpha minus K cos alpha. And let's take this KL to the other side. So is equal to KL. So C is KL divided by sine alpha minus K cos alpha. Okay, we found out C. Now the question is, what's the work done by the friction forces along the entire journey? Now let's look at this one. So we have to find WFAB plus WFBC. Okay, these two sum. And what is that? That is equal to minus of work done by gravity in the journey AB. Okay. So work done by gravity in the journey AB is mg sine alpha into C. So minus, minus mg sine alpha into C. And we can substitute, let me write this down, and then we can substitute the value of C from here. So minus mg sine alpha times, we can write KL divided by sine alpha minus K cos alpha. Now if I divide sine alpha both sides, if I divide numerator and denominator by sine alpha, so this becomes minus K mgl divided by 1 minus K cot alpha. So the work done by all the friction forces is equal to minus kmgl divided by 1 minus k cot alpha. And the value here will be negative because work done by friction forces is always opposite to the displacement. Okay, so that's the answer.